Hello and welcome to this week's episode of Quick Code Wednesday. Today we'll talk about linked lists. We'll implement one using JavaScript, but the concept can easily be translated to any other programming language. Before we start coding, let's see what exactly is a linked list. Now, like arrays, they are a way of storing several items at once, but unlike arrays, a linked list elements are not stored in a contiguous location. The elements are linked using pointers. We'll be calling these elements nodes from now on. So each of these nodes has two properties in the case of a singly linked list. A data property that will hold the data and the next property that is a reference or pointer to the next node. The first node is called the head and the last node will be pointing to null. We also have a doubly linked list, and as you probably guessed, we have an additional property called previous, and this one is pointing to the previous node. So the next property will point to the next node, the previous property will point to the previous node. The rest is exactly the same. And for the circular linked list, we have the last node, next property pointing to the first node. We would like the list to have a bunch of methods, one to add at the end, one to remove from the end, to insert and remove from a given index, to get a node on a given index, and to print the list in console to help us test faster. Let's implement one here. We'll need a class, we'll call it linked list, which will have a constructor, and in this constructor we'll have the head will be null at first, and let's also have the size, which will be 0. We need to create nodes, so we'll also implement a node class called node, and this one will also have a constructor, but this time we'll have the data passed down in the constructor. So this data will be data, and then this next property will be null at first. So we said that we need a method to add a node at the end of the list. So let's call it push. We'll be passing the data through the method. We need to create the node. So now we'll have to check if the list is empty first. So if this dot, otherwise we need to traverse the list at the very end. So until next is different than null, we need to change the current variable with current.next. Current.next will be becoming the new node, and at the very end we'll need to increment the size. Okay, so this is it with the push. Let's now create the print method, just so that it will be easier for us to test. And we'll also have a string which will be used to build the string that will be console logged. Which will be the string that we just created, and then for formatting purposes let's have something like this. So we need to export this one. And let's test this out. Let's import it first. Then let's push a bunch of elements. So we have a size of 2 and the list is A and B. Okay, so we've done this one and we also have done this one. So let's remove from the end. Let's call this method pop. Here we need to traverse the list until the very end, and then remove the last element. Until not the very end, but the element before that. Then we also need to decrement the size. So the list is now 1. Size 1, and the data is only A. We've done this as well. Let's move forward, insert a node at the given index. Okay, so for this one, we first need to check that the index is greater than 0 and smaller than the size of the list, right? Otherwise, we need to first create a node. So the next property of the node that we want to insert will be the head. At this time, we iterate only until we get to the index. So if the iterator is smaller than the index, we insert it between the previous and the current node. Okay, and then we also need to increment the size. Great, let's test this out as well. And then let's print. We have an issue here. It works now. It's done as well. So remove from a given index. Let's call this method remove from index. We'll get the index we want to remove. And here we also need to check the validity of the index. And then we'll need to check if the index is 0. So if we want to remove the very first item, so the head will be pointed to the next node. Then we need to remove, so previous dot next. Great, so let's test this out. Start, move from index. Let's remove the one in the middle. So let's remove from index 1. Yep, so one disappeared. Okay, so we only have the get method to do. Get a node from a given index. So let's call it get node at index, and we'll also receive the index here. And we'll also need to do a guard clause for the index. And let's just say this is not valid. So until the iterator is greater than the index, we will be doing a check here. And this is working. You will be asking why use linked lists. So advantages is that they are a lot more flexible in the way that the memory is allocated for the nodes, and it is easier to insert and delete nodes. For example, as you probably noticed, how simple it is to insert at the beginning of the list, right? It's just 2 lines. And also to remove an element from the beginning of the list. But they also have some disadvantages. The random access is not allowed, so we had to implement a method, this one, get node index, to get the element from a given index. They also use extra memory space for the pointer, right? Because we have 2 properties, the data and the pointer for the next or previous one. And they are also not cache friendly. So since array elements are in a contiguous location, they are much easier to get an element from an array if it is cached. I would start with an array and move to a linked list as an optimization step. You can consider this as another tool in your toolbox, and each tool has its own place where it shines. Now, this will be it for this week's episode. Don't forget to like, share, and subscribe. Thank you for watching.